In this video demonstration, we will explore how an ASD tug maneuvers. An ASD tug will use units that can rotate 360 degrees and apply throttle. This results in a direction and speed, which the water is propelled away from the unit. The resultant force is dependent on how both units are set up. In this case, we have both units turning inward, propelling water away from the tug. This results in a neutral position for the tug. It doesn't go forward and it doesn't go aft because both of the forces cancel each other. Now we're going to open up the tug. We're going to open it up to about 60 degrees of azimuth. And at 60 degrees of azimuth, once we continue the simulation, they will turn and they're going to now start to produce a forward movement. Now we're getting up to about half of a knot of forward movement. As the tug starts to gain speed, we can then choose to open up the tug even more. In this case, we're going to put it up to 30 degrees of azimuth for both units. Once set, we'll start the simulation again. And we'll notice that our tug will start to gain speed as the units rotate more in a forward and aft direction. So now we're getting up to about a knot, just under a knot and a half. If you want to now check that speed, you can go back to the neutral position by putting both units directly inward. They will rotate and now start to propel water away from the vessel. Now the tug is going to slow down in speed. As you can see, it's just under a knot now. If you find that you're not slowing down quick enough, you can then rotate both units so that they're propelling water in a aft direction. In this case, we're going to set both units to about 30 degrees abaft of the beam. Here on the starboard unit is now going to propel water towards the head, and now the port unit as well. And you'll notice once we start the simulation, we'll slow down even quicker. To examine this further, let's take a top-down view of what we're looking at. Here we essentially have an x-axis, or port and starboard, and a y-axis, fore and aft. As we adjust the port and starboard unit, we adjust both the direction and the speed, which we can produce a thrust away from the tug. Looking at this in closer detail, we see when we move our port unit inward, we're creating a vector that is outward. When we move our starboard unit inward, we're also creating a vector outward when we apply the throttle. Both throttles have now been applied, the forces cancel each other out. However, should we then choose to open up the units, what we would do is we'd move the port unit forward, approximately 30 degrees, and the starboard unit forward. The result is that both unit creates a vector with both a direction and speed. The lateral forces will cancel each other out, whereas both forces pushing the tug ahead would be added together, creating a resultant force. So what we'd do is we'd take away the two lateral forces, and then we'd add the two forces that would be together, pushing the tug ahead. This was known as a resultant force. If we're then to open up the throttle even more, by say putting it to just 30 degrees off of direct ahead and stern, we've now reduced the amount of port and starboard thrust and increased the amount of thrust fore and aft. If we were then to put both units directly ahead, all of the force now is being directed out the stern of the tug. So there is no lateral force that is canceled out. It's just all pushed. And then if we want to stop the vessel, we'd put them both inward, and all the thrust now is to port and starboard, which then would cause them to quickly cancel each other out and slowing down the tug. This concludes the video demonstration for ASD maneuvering. The key takeaway is that units are going to create a thrust. This is both direction and speed. Together, these will determine how the tug maneuvers in the water.